Hi there. So let's go through the theoretical test for the dolphin therapy experiment, okay? We will also check this using GeoGebra, and we'll do the confidence interval on GeoGebra to get a comparison between the two, okay? So we've got our dolphin therapy experiment. We've got our data from this previous page right here, and we wrote out our hypotheses already. I'm going to write them out using the word control now instead of the letter C, because now we know we need C for combined. So I'm going to rewrite our hypotheses here. So the null, H naught, P sub D for dolphin is equal to P sub control. Right, so the dolphin group is equal to the control group. There's no difference between the proportions that were improved by swimming with the dolphins. Or if you want to do the subtraction way, P sub D minus P sub control is equal to 0. That's another way to say there's no difference. Okay, the alternates. P sub D, we wanted to know that depression was improved. So the dolphin group by the dolphins. So the dolphin group proportion improved would be greater than the proportion for the control group. And same idea with P sub D minus P control greater than 0. Okay, so this was a right tail test, or is a right tail test. We did it with simulation already. Okay, now I'm going to do our P hat C, which is the combined, and mentioned that in the last video that if there's no difference between the groups, that means these folks were going to improve either way. So we're counting those as 13 out of 30. Okay, I'll write out the formula where we add the 10 plus 3 over the 15 plus 15 to get 13 over 30. And let's get a decimal for that, since we'll need this in our formula coming up. 13 out of 30 is 0.43 repeating, so 0.4333. Okay, or you could also write approximately equal there. Okay, and remember, these are the improvers. Okay, so that is our assumption for the null being true. Okay, so let's write out the conditions, and I have my sheet right here. So individuals in each group and between groups must be independent of each other regarding the variable measured. So let's write about that. So each participant independence or each subject is shorter must be independent in terms of having depression. Okay, and so that's between and within the two groups. Okay, and then of course we should consider all of our other factors. I'm going to say age, gender, race, and ethnicity, income. Yeah, so I'm sure there's other things you could think of as well. Okay, randomization. Okay, so we need, because this is an experiment, we need random assignment. of the two groups. I'm pretty sure that was in the problem statement. Okay, large population. Okay, so we would not count the same person twice in the in an experiment, so we are sampling without replacement, so this applies. So we need to look at the population, and this is really a single population of folks diagnosed with mild to moderate depression, so I'm going to write it in terms of a single population. Population of people diagnosed with clinical depression must be 10 times each sample size. And because they're both 15 in this case, I only need to do it once because 10 times 15 is 150. I'm sure that is definitely met. If we had two different sample sizes, we would do it for each one. Okay, so that is met. The last one is success failure. And we need to do that one with the p hat c, right? Because we're assuming the null is true. We're going to use that. Okay, so I'm going to write n1 p hat c is 15 times our 0.4333 is 6.449, about 6.5. So as you can see, this is not coming out to 10 people. Let's go ahead and do the rest of them. N1Q hat C is 15 times 1 minus 0.4333. I'll do approximately for that one as well. 15 times 1 minus 0.4333. That is also not even 10, so about 8.5. Okay, and then because N2 is also 15, those would be a repeat, so I'll just make a note of that. N2 is also 15. So these would repeat. Okay, so these are not greater than or equal to 10. I'm going to put a slash through that. And take a look at our data. You might have been noticing that right, we're supposed to have expect 10 successes and 10 failures in each group. Well, we can all see from the actual data that we only have 10 and 3 and 5 and 12. If we were going to have 10, 10, 10, 10, we would need at least 40 people in our experiment. So these conditions are not met. It's possible that that different methods were used in the study. This is sort of based on a study that happened. We're going to continue with the problem for practice, okay? But this is something you would want to look at before you collect data and do an experiment, okay? So this is not met. But we will continue for practice. Okay, and that will usually be the case. We're always going to do the problem. I try to make sure they're met, but it could happen where they're not. So we're going to do it for practice. Okay, great. So the next step, let's go to our steps. We've got our conditions, the observed statistic, and the test statistic, right? So So our p hat 1 minus p hat, D for dolphins and control. Gotta switch over. That is our 10 out of 15. Dolphin minus control, yeah, 10 out of 15 minus 3 out of 15. Okay, and we can get a value for that. That is 0.466. So 4 and 2/3 repeating. That's interesting. 4.67. Sorry, 0.4667. Okay, just keeping 4 digits. And then we have our p hat c up here. So let's write our z-score. Our z-score equals, so it's going to be our p hat dolphin minus p hat control. Right, that's our observed statistic, minus 0 because the null value is that they're the same, over, and this is going to be the combined one, p hat c q hat c times parentheses 1 over n1 plus 1 over n2. Okay, so let's plug in our numbers there. So on the top we have 0.4667. And then we have our p hat combined is 0.4333. Then 1 minus that. And then 1 over 15 plus 1 over 15. Okay, so that is our test statistic. I'm going to use Desmos online calculator. I would recommend that, but of course you can use your handheld as well. Let's see, yes, I've got it right here. Okay, so we've got 0.4667 divided by square root 0.4333 parentheses 1 minus 0.4333, and close those and open, and I'm still in the square root. I'm always checking that. 1 over 15, I need to hit the right arrow to get out of the denominator of the fraction, plus 1 divided by 15. And I can close that end one or not, it'll do it for me, which is really nice. Okay, so make sure your calculation looks like that, and I'm getting 2.5793, it looks like, to round. Okay, let me write that down and I will put it over. If you kept the fraction the same, and like the exact fraction on the top, it would come out slightly different, so it's okay. It's expected that these might be a digit or two on the end off because of depending where someone rounds. Okay, great. So we know that that's getting pretty unlikely, right? Over 2.5 standard errors away from the null, but we want to see, right, how unlikely that is. So, and I'm going to write standard errors from the null value of 0, just to remind us what that means. Okay, the p-value is the chance of that happening, right? So p-value is going to be a probability that z is greater, because we're doing a right tail test. We want to know if anything this far or to the right or further towards the tail. What's the chance of that? So 2.5793 Let's see what that is equal to. So I'm going to go to Staplet Normal. And we're talking a z-score, so we put in 0 and 1. Okay, and we're doing a right tail test, so to the right. 2.5793. Calculate area. Okay, great. And we can see it is quite small. 0.005. And I'm just going to double check with this rounding link at the bottom that I do have round to as many as 4, so it must have been cut off right there. So 0.005. Okay, very small, right? And I'm double checking. It doesn't look like we have a significance level. Okay. But this is definitely smaller than most significance levels, so I will say it is less than 0.05, which is our default significance level. And let's write our conclusion. Okay. With a p-value of 0.005, we reject the null. Hypothesis. There is, or we have, strong evidence that the dolphin group improved in their depression more than the control group. You could even say significantly more. Okay. Great, so that is our full theoretical test. Now I want to compare this with a confidence interval. Well, I want to do a couple things. I want to check this on the GeoGebra calculator, and then I also want to make a confidence interval and compare, would it give the same result? Okay, so remember we're going to do both of these together, and together that will give us a complete picture. Okay, so first of all, we've got to figure out what would our confidence level be that matches this, right? That matches this test, okay? So I like to draw a little picture. We have a one-tail test. So we had a right tail test, and I just used 0.05 for the significance level. So that means in the left tail, there would also be 0.05, and we need to do a 90% confidence interval, right? So I just did 1 minus 2 times 0.05 if you prefer the formula way. I did the whole of 1 minus the 2 tails is going to be 1 minus 0.1 or 0.9. Okay, so we need a 90% confidence interval. Okay, now we can do it on Staplet or StatKey. We can do StatKey or GeoGebra. I'm going to go to GeoGebra because I want to check our p-value and everything on there. So I'm going to go to z-test for difference of proportions, and you can see it looks like you can edit that 0, but you can't. So the difference of proportions, the null should always be 0. We have a right tail test, and now I need to put in my successes for each group. So 10 out of 15 and 3, and you can also use tab to go between these out of 15. Okay, so let's double check. So z equals 2.5791. Okay, that's very close, just a couple of digits due to rounding. And a p-value of 0.005. Okay, excellent. So that also agrees. So let me make a note on that. Make a note over here, GeoGebra. Check our z is 2.5791. But you can also see it doesn't affect the p-value. P-value is 0.005. Okay, so that checks out. Let's go to z estimate, difference of proportions right here. And what's wonderful is it kept my data there, the 10 out of 15 and 3 out of 15. I love that. I do need to change the confidence level because it didn't know our significance level. So I need to change that. And so we would get a confidence interval of 0.2041 to 0.7292. So let me write that down. Okay. Okay, let me move this up. So I wrote that down right here. So here's our confidence level. And then remember confidence interval. When we are comparing a confidence interval with a test, we're looking at where is that null value, right? And the null value is 0. Okay, or maybe I should go to the right. This interval is all above 0. So that's what we're looking for in a right tail test. We want the direction of the interval to be in the direction of the alternate, right? If the null value is not in there, it's not a plausible value. Okay, so this is essentially saying the dolphin group is improved by 20% to 70, almost 73% more than a control group in this scenario, right? So let's write that down. So they do agree. Okay. So we could say with 90% confidence. And we could also practice this on StatKey as well. With the bootstrapping, it should come out pretty similar. So I'll write that this is from GeoGebra. Okay. With 90% confidence, I'm going to actually rephrase this just a little bit because I need to go back. I need to go towards the population. Swimming with dolphins can improve clinical depression. Now we could say in a percentage of participants. I think that's what I'm going to do because we're talking about proportion of those improved. In 20.41% to 72.92% of people. Okay, I'll have to be very careful when wording these things, right? So in this case, the hypothesis test and confidence interval agree. Okay. And we did have that full positive to positive interval, just reviewing that a little bit. which means the first group was higher, right? So the improvers in the dolphin group were higher than the control group. Okay, great. I hope that helps. Thanks for watching. I'll see you in the next video.